Welcome to CloverDX Data Manager series. We're looking at reference data management for CloverDX developers using Data Manager. I will show you how you can use Data Manager to work with lookup tables that are maintained and managed by the business users who are responsible for the data. For all data engineers, lookup tables are an essential part of your data pipeline. You use them for things like state, country codes, for product catalogs, for all kinds of data that changes infrequently. But inevitably, they do need to change. You add new products to your catalog, Swaziland becomes Eswatini, data changes. Unfortunately, it's not usually you, the data engineer, who's in charge or even aware of when these data changes. But it is you who's in charge of maintaining the tables. So you get emails or Jira tickets or even a colleague at the coffee machine telling you to change some field somewhere or add new products to the catalog. But now, with Data Manager and reference datasets, those colleagues who are responsible for knowing the data, I'll call them business users, can also be the ones responsible for keeping that data updated in the lookup table. Here's how this works. A reference dataset will be created by the Data Manager admin, and this is what one might look like. This dataset has the information about the addresses and phone numbers for our stores, which we use to send product shipments. This doesn't change much, but from time to time changes happen. We add a new store or a store changes addresses. This is where the business user will work in maintaining the data. They can edit fields where data has changed or add new rows, even enable and disable rows when relevant. Once they make changes and click Approve, that data is instantly available for us to read from our Clover graphs. You can also add records to the reference dataset from a Clover graph using the Reference Dataset Writer component. This is particularly useful for the initial setup of your dataset or anytime you're adding large batches of data to it. All you need to do is select your dataset and then your input mapping. If your incoming fields have the same names and data types as the dataset, you can skip the mapping. It'll do it by default. Otherwise, open this dialog and you can see the dataset fields on the right that you need to map to. Most of the fields can be null, even the key field. Our business users can fill those in Data Manager, but not enabled. Enabled needs to be set to true or false so the Data Manager knows which state it should begin in. Then, when we run this, all of our data will be sent to the dataset. Only one step is left before we can start using this data. The business user responsible needs to approve it in the Data Manager. Then, we can just read all of our data and access it right from within our graphs. Let's see how that works. This is a simple graph which takes a list of purchase orders and matches them with information from our products reference dataset and our stores reference dataset to create a shipment report. First, we've got a flat file reader for our purchase orders and a reference dataset reader for our product catalog. When we open the reference dataset reader, you can see that we need to select our dataset and then the record status we're looking for, enabled, disabled, or all. It'll default to enabled. And then we map the fields that we want to take from the dataset. In our case, just these 4 fields. Now, we can merge that data with our purchase orders on product ID and use it however we need in our graph. In this simple case, we're just writing the orders to a spreadsheet. The other way we can use reference datasets in our graphs is with the lookup join component. First, I need to go down here to lookups and add reference data lookup table. There I will select the reference dataset that I want to use. It'll automatically fill out these properties here. And then I just name it and click Finish. Now, from the lookup join component, I need to select our stores lookup table. Then select the join key. This needs to be the key field from the dataset. Here it's store ID. And then it's also asking me for a timestamp this time. This is because this reference dataset has effective dates enabled, which allows us to keep different versions of the same piece of data with the date determining which one is used. In our example, store 1989 is about to move from Oakland to Sacramento. So we already have a second row for it, with the date set for when that address will become the valid one. This way, our automation will seamlessly switch to the new address without us data engineers doing a thing. So our order date here is the timestamp, which will determine which version of the store ID to use. Now we just map the fields that we want, and for each record that comes into the lookup join, we'll get the data that we need for that store from the reference data set. And it'll continue along in our transformations, here adding the store address to our shipment reports. So now you have persistent lookup tables of the highest quality because they're maintained by the business users themselves, the domain experts who know when a new product is added or when an address is changed. And you can focus on creating automations instead of updating tables manually.